Hello friends, welcome to today's research program. So today I will continue the same problems, linear equations, which I have explained in the previous class. The next problem is solve dy by dx plus y into tan x is equal to cos x. It is a linear equation. It is in the form of dy by dx plus py is equal to q, where p and q are functions of x. Solution: given p is equal to tan x and q is equal to cos x. To solve this linear equations, first we have to find the integral factor if. This is equal to e to the power of integral of p dx. This is equal to e to the power of integral of p value is tan x with respect to x. Integration of tan x with respect to x, that is equal to e to the power of log of secant x. E to the power of log of secant x. Integration of tan x with respect to x is equal to log of secant x, and we know that e to the power of log x is equal to x. Therefore, this is equal to e to the power of log of secant x is equal to secant x. This is the integrating factor. Now, the solution is formula y into integrating factor if. This is equal to integration of q into integrating factor dx plus k, that is y into integrating factor is secant x, q is cos x, if is secant x dx plus k. Cos x into secant x, these two are reciprocals to each other. We know it very well. In the previous class, in the previous sum, you have studied about trigonometry. Cos x and secant x are reciprocals to each other. Therefore, that is equal to, integration of 1 with respect to x is x plus k, where k is integral constant. Therefore, solution is y into secant x is equal to x plus k. This is the solution of the given linear equation. Let us see the next one. I want to recollect the points. Dy by dx, solve dy by dx plus y into cot x is equal to 5 into e to the power of cos x y is equal to 4 when x is equal to pi by 2. In this, he has given y is equal to 4 when x is equal to pi by 2, because to find the value of k, after finding the solution, substitute the value of y is equal to 4 and x is equal to pi by 2, you will get the value of k. So, that is the value of the integral constant. Solution: Again this is a linear equation where P is equal to cot x and Q is equal to 5 into e to the power of cos x. Integrating factor is equal to e to the power of integral of p dx, e to the power of integral of cot x with respect to x. Integral of cot x is equal to e to the power of integral of cot x is log of sin x, So this is equal to sin x. Therefore the solution is y into integral factor is equal to integration of q into integral factor dx plus k, that is y into sin x 5 e to the power of cos x into sin x dx plus k. So this we have to integrate now. 5 is constant, we have taken outside. Put cos x is equal to t, differentiate with respect to x, minus sin x dx is equal to dt, that is sin x dx is equal to minus dt. This is equal to 5 integration of e to the power of t minus dt. This is equal to minus 5 e to the power of t plus k, that is y into sin x is equal to minus 5 e to the power of cos x plus k. This is the solution of the given linear equation, but extra is expecting from us when y is equal to 4, if y is equal to 4 when x is equal to pi by 2. Put y is equal to 4 and x is equal to pi by 2. 4 into sin pi by 2 minus 5 into e to the power of cos pi by 2 plus k, that is sin pi by 2, sin 90 degree, that is 1. This is equal to minus 5 e to the power of cos pi by 2, cos 90 degree is 0 plus k, that is 4 is equal to minus 5 plus k, e to the power of 0, n to the power of 0 is equal to 1. Therefore 1 into minus 5, that is equal to minus 5. Therefore k is equal to 9. So the integral constant is 5. The solution is y into sin x is equal to minus 5 into e to the power of cos x plus 9. K value is 5. So to find the value of integral constant, he has given when y is equal to 4, x is equal to pi by 2. So using that you can find the value of the k, substitute in the solution. Now we will see the how to reduce the given differential equation into linear equation, that is called Bernoulli's form of equation. Bernoulli's form of equation. Bernoulli's differential equation. an equation of the form dy by dx plus py is equal to q into y to the power of n, y to the power of n, where p and q are functions of x, is called Bernoulli's form of differential equation. Bernoulli's form of differential equation. How to solve this equation? First, we have to reduce this equation into linear form of equation. That means linear equation dy by dx plus py is equal to q. First, we have to bring this equation into linear form of equation. That means we have to reduce this equation into linear equation. Then we have to solve the equation as it is in the previous problem. This can be reduced. This equation can be reduced into linear equation by dividing this equation by y to the power of n and t is equal to y to the power of 1 minus n. First, we have to divide the equation by y to the power of n. Next, we have to substitute the value of y to the power of 1 minus n or 1 over y to the power of n minus 1, that is equal to t. The remaining thing is as it is in the previous class. Now, while doing the problem, you will understand how you are going to divide the equation by y to the power of n, and for what we are going to substitute the third variable. Solve y squared dy by dx is equal to x plus y cube. Solution: given y squared dy by dx is equal to x plus y cube, that can be written as y squared dy by dx minus y cube is equal to x. So, here y to the power of 0 is there 1, so that is not necessary to divide this, but here minus y cube is there. Put minus y cube is equal to t, differentiate with respect to minus 3y squared dy by dx is equal to dt by dx. Sorry, this is differentiate with respect to x, that is y squared dy by dx is equal to minus 1 by 3 dt by dx. See, this one that is equal to minus 1 by 3 dt by dx. That can be minus 1 by 3 dt by dx minus, already we have taken minus y cube. So, plus 1 is equal to x, that is equal to t, minus y cube is equal to t. So, plus t is equal to x. See, this is a linear equation in t. This is a linear equation in t. That can be written as dt by dx minus 3t minus 3x. Take LCM and cross multiplication, multiplied by the minus sign. This is minus into minus plus, plus into minus minus, this is plus into minus minus. So, now this is linear equation in t. P is equal to, in this, minus 3, q is equal to minus 3x. So, integral factor is equal to if is equal to e to the power of integral of p dx. This is equal to integral of minus 3 dx. 3x. Therefore, solution is t into integral factor. You have to remember this. This is linear equation in t. Therefore, while writing the solution, in the place of y, we have to take t. T into integral factor. This is equal to integration of q into integral factor with respect to x plus k. That is t into integral factor, q value is minus 3x into e to the power of minus 3x with respect to x plus k. This is minus 3 I have taken outside, x into e to the power of minus 3x dx plus k. See how to integrate this. T into if is equal to so much, minus 3 into this, u is equal to x, v dash is equal to e to the power of minus 3x, differentiate with respect to x, u dash is equal to 1, v, here v dash we have taken integration by parts. The first function is equal to x, the second function v dash is equal to e to the power of minus x, but I want v, so we have to integrate this e to the power of minus 3x by 3, this minus this minus this. That is equal to x into e to the power of 3x by minus 3 minus integration of 1 into e to the power of minus 3x by minus 3 with respect to x. So, this is minus x into e to the power of minus 3x divide by 3 minus into minus plus 1 over 3 e to the power of minus 3x by minus 3 plus k. Therefore, the solution is t into if. T is minus y cube. T is minus y cube. If is integral factor e to the power of minus 3x is equal to minus 1 over 3 if I take constant minus x into e to the power of minus 3x plus e to the power of minus 3x by 3 plus k. If you want, you can take the e to the power of minus 3x also, that is minus y cube e to the power of minus 3x minus e to the power of minus 3x by 3 x plus plus k. So, this is the solution of the Bernoulli's form of equation. Now, we will see the next problem, the second one. The second one, solve x into dy by dx, x into dy by dx plus y is equal to x cube into y to the power of 6, x cube into y to the power of 6. Solution: x into dy by dx plus y, x cube y to the power of 6. First, to divide by this equation by x, dy by dx plus 1 over x, x squared into y cube, sorry, y to the power of 6, not this is dy by dx plus py is equal to cube into y to the power of n, according to as it is as in the Bernoulli's form of equation. Divide by y to the power of 6, 1 over y to the power of 6 dy by dx plus 1 over x, 1 over y to the power of 5 is equal to x squared. First, we have to divide by y to the power of 6. Next, we have to substitute. Put t is equal to 1 over y to the power of 5. So, that is y to the power of minus 5. Differentiate with respect to x. Differentiate with respect to x. dt by dx is equal to minus 5 y to the power of minus 5 minus 1. This is minus 5 y to the power of minus 6. That is minus 1 over 5 dy by dx, sorry, dt by dx is equal to 1 over y to the power of x dy by dx. Look here friends, minus I have taken this side and 5 I have taken in the denominator. So, minus 1 over 5 dt by dx, that is equal to y to the power of minus 6, y to the power of minus 6 into dy by dx. Y to the power of minus 6 can be written as 1 over y to the power of 6 into dy by dx. So, in the place of 1 divided by y to the power of 6 into dy by dx, in that place we are going to substitute in the equation minus 1 over 5 dt by dx plus 1 over x into t is equal to x squared. Is it? In this place, this is equal to minus 1 over 5 dt by dx plus 1 over x. This value is equal to, we have taken it as a t. So, that is equal to x squared. That is dt by dx minus 5 by x t minus 5x squared. Take LCM and cross multiplication. dt by dx minus 5t by x is cross multiplication. So, minus sign is there, minus into minus plus, plus into minus minus, plus into minus minus. So, this is a linear equation in t. This is a linear equation in T, where P is equal to minus 5 by x and Q is equal to minus 5x squared. Similar process, integrating factor is equal to e to the power of integral of p dx, integral of minus 5 by x dx. This is equal to e to the power of minus 5 log x, e to the power of log of x to the power of minus 5. This is equal to x to the power of minus 5. E to the power of log x is equal to x. Same way, e to the power of log of x to the power of minus 5. So, that is equal to x to the power of minus 5. Therefore, the solution is t into integrating factor. In the place of y, we have to write t into integrating factor is equal to integration of q into integrating factor dx plus k, that is t value is y to the power of minus 5, if is equal to x to the power of minus 5 is equal to integration of q value is minus 5x squared, if is x to the power of minus 5 with respect to x plus k. This is equal to minus 5, I have taken outside, x square into x to the power of minus 5, that is equal to x to the power of minus 3 with respect to x plus k. See here, x to the power of n into x to the power of m, x to the power of m plus n, m value is 2, n value is minus 5, that is equal to minus 3. This is equal to integration of x to the power of n, x to the power of n plus 1 divided by n plus 1 plus k. So, this is equal to minus 5 x to the power of minus 2 by minus 2 plus k. So, this is equal to minus into minus plus 5 by 2 x to the power of minus 2 plus k. Therefore, the solution is y to the power of minus 5 into x to the power of minus 5 is equal to 5 by 2 x to the power of minus 2 plus k. This is the solution of the Bernoulli's form of equation. First, we have to verify that whether the given equation is Bernoulli's form. Then we have to reduce the given equation by putting t is equal to y to the power of 1 minus n, y to the power of 1 minus n. Then automatically you will get the linear equation in T. You know it very well how to solve the linear equation. First we have to find the integrating factor, then formula, but we have to remember while writing the formula, in the place of y, you have to take the variable which you have substituted. Here we have taken the substitution variable is t. T into integral factor, that is equal to integration of q into integral factor with respect to x plus k. Now we will see the third one. Solve dy by dx minus 1 over x y squared is equal to minus 2 y squared. minus 2y squared. This is wrong, y is not y squared, this is y. Solution: the given equation is itself in the form of dy by dx plus py is equal to q into y to the power of n. Given dy by dx minus 1 over x into y minus 2y squared, divide by the equation by y squared, that is 1 over y squared dy by dx minus 1 over x 1 over y minus 2. Put minus 1 over y is equal to t. To avoid the negative sign, I have taken minus 1 over y. Otherwise, even if you want, you can take 1 over y is equal to t. Differentiate with respect to x. Minus is there. Minus 1 over y squared dy by dx is equal to dt by dx. That is minus into minus plus 1 over y squared dy by dx is equal to dt by dx. Look here friends, here minus 1 over y is there. So, this is minus y to the power of 1. This can be written as minus y to the power of minus 1. Minus is there, minus derivative of y to the power of minus 1. Minus 1 into y to the power of minus 1 into dy by dx. Minus 1 minus 2, y to the power of minus 2. So, 1 over y squared. So, that is equal to 1 over y squared dy by dx is equal to dt by dx. So, this in this place we can substitute dt by dx. That is, the equation become dt by dx. I have taken minus 1 over y is equal to t. Therefore, it is become plus is equal to minus 2. RHS is minus 2. Here I have taken minus 1 over y is equal to t. Therefore, this is become plus. So, it is linear equation in t where p is equal to 1 over x and q is equal to minus 2. Integral factor is equal to e to the power of integral of p dx, e to the power of integral of 1 over x dx, e to the power of log x, that is equal to x. Therefore, the solution is p into integral factor is equal to integration of q into integral factor with respect to x plus k. That is, t value is minus 1 over y, I of integral factor is equal to x. This is equal to minus 2 into x dx plus k. That is, minus x by y is equal to minus 2 integration of x with respect to x, x squared by 2. 2 get cancelled. That is minus x by y minus x squared plus k. That can be written as in the order we can write x squared minus x by y is equal to k. This is the solution of the given Bernoulli's form of equation. Again the same thing. So, you have to observe that dy by dx plus py is equal to q into y to the power of n. When y to the power of n is there, first you divide the equation by y to the power of n. So, automatically you will get the next step. Now, we will see the next problem, that is the last one in this Bernoulli form of equation. Fourth one, solve the equation x into dy by dx, x into dy by dx plus 1 minus x into y is equal to x squared y squared. We know it very well, y squared is present, therefore it is a Bernoulli's form of equation. So, we have to divide by y squared, but we know it very well, dy by x into dy by dx is there, x should not be here. So, divide the equation by x into dy by dx plus 1 minus x into 1 minus x into y, x squared y squared. If you want to do twice, first you divide by x, next you divide by y squared. Otherwise, divide the equation by x into y squared. So, this is 1 by y squared dy by dx plus 1 minus x by x into 1 over y is equal to x. Am I correct? See, in the place x cancel 1 over y square dy by dx plus 1 minus x divided by x, but here y is there, we are dividing by y squared 1 over y. We are dividing by x into y squared. So, y squared get cancelled, here x squared is there, by x, 1x get cancelled, x is left here. So, here again put 1 by y is equal to t, that is y to the power of minus 1 is equal to t. Differentiate with respect to x, differentiate with respect to x, that is minus 1 y to the power of minus 2 dy by dx is equal to dt by dx, that is y to the power of minus 2 dy by dx minus dt by dx, minus dt by dx, that is 1 over y squared dy by dx is equal to minus dt by dx. So, in the place of 1 over y squared dy by dx is equal to minus dt by dx plus 1 minus x divided by x into t, that is equal to x, that is minus dt by plus 1 minus x into t is equal to x, that is dt by dx minus 1 minus x divided by x t, this is equal to minus x. It is linear equation in t, that is a linear equation in t. P is equal to minus 1 minus x by x and q is equal to minus x. Find the integrating factor. if is equal to e to the power of integral of p dx e to the power of integral of minus 1 minus x by x dx. This is equal to e to the power of minus integral of 1 over x minus 1 with respect to x. So, this is equal to e to the power of minus log of x minus x, e to the power of log of x minus x. So, this is equal to IF is equal to e to the power of minus log x plus x. This can be written as e to the power of minus log x into e to the power of x. So, this can be written as e to the power of minus log x is equal to e to the power of log of x to the power of minus 1 into e to the power of x. So, x to the power of minus 1 e to the power of x. This is equal to e to the power of log x to the power of minus 1 is x to the power of minus 1 e to the power of x. So, this can be written as x by x. See, you have to concentrate integrating factor here. See, e to the power of integral of p dx, p value is minus of 1 minus x divided by x. Minus I have taken outside, 1 by x, minus is there, x by x is 1. So, integration of 1 over x is log x, minus is there outside, minus of integration of 1 with respect to x, x. This integration of e to the power of minus log x, minus into minus plus x, that can be written as e to the power of minus log x e to the power of x. But minus I have taken here e to the power of log of x to the power of minus 1 into e to the power of x. We know it very well, e to the power of log x is equal to x. So, x to the power of minus 1 into e to the power of x, this is equal to e to the power of x by x. Therefore, the solution is t into integral factor q into integral factor dx plus k. What is the value of t is 1 by y, integral factor is e to the power of x by x, q value is q is equal to minus x into e to the power of x by x dx plus k. T, that is 1 over y, integral factor e to the power of x by x is equal to q into integral factor, q value is minus x, integral factor is e to the power of x by x with respect to x plus k, x get cancelled. This is equal to minus integration of e to the power of x with respect to x is e to the power of x plus k. Therefore, solution is e to the power of x divided by xy plus e to the power of x is equal to k, where k is integral constant, So, linear equations, first you have to concentrate linear equations. Dy by dx plus py is equal to q. This form of equation is called linear equation. That is, the Bernoulli's form of equation is extension of that. First we have to reduce the Bernoulli's form of equation into linear equation. Then only we can find the solution of the Bernoulli's form of equation. Now we will see the next. second order homogeneous linear differential equations. Second order homogeneous linear differential equations with constant coefficients. Second order, we know it very well in that equation, d squared y by dx squared must be present. Then only we are going to call it as a second order differential equation. That means that is the highest order of the differential equation, d squared y by dx squared. Homogeneous equation, the equation must be equal to 0, that is not equal to some other function. Then we are going to call it as a homogeneous linear differential equations with constant coefficients. How to solve the second order homogeneous linear differential equations having constant coefficients? How to solve such type of equations? Now we will see. Consider the second order differential equations with constant coefficients a into d squared y by dx squared plus b into dy by dx plus cy is equal to some function. This is not a homogeneous equation. If it is equal to f of xy equal to 0, then it is called second order homogeneous differential equation. So this is equal to 0, then only we are going to call it as a homogeneous equation. Now we are speaking about the second order homogeneous linear equation. Therefore we have to consider a into d squared y by dx squared plus b into dy by dx plus cy is equal to 0. Similarly, you can consider the third order homogeneous linear equation. So the highest order of the differential equation is 3, then we are going to call it as a third order homogeneous differential equation. Now according to your syllabus, you are having only second order homogeneous equations. How to solve this? Coefficient of d squared y by dx squared is a, coefficient of dy by dx is b, coefficient of y is c. Put d squared y by dx squared is equal to d squared y, dy by dx is equal to dfy. That is, the equation becomes a into d squared y plus b into dfy plus 0. That can be written as a d squared plus bd plus c of y is equal to 0. That can be written as f of dfy is equal to 0. F of dfy is equal to 0. That implies f of d is equal to 0. F of d is equal to 0. That is a into d squared plus b into d plus c is equal to 0. Put in the place of d is equal to m, then it becomes am squared plus bm plus c is equal to 0. This equation is called auxiliary equation. This equation is called auxiliary equation. Auxiliary equation. This equation is called the auxiliary equation, and we know it very well. This equation is a quadratic equation. This equation is a quadratic equation. Every quadratic equation having two values, that is called the roots of the differential equation. Okay, how to solve this equation we will see in the next class. Thank you.